Okay, so we have two types: mechanical system, linear mechanical, and rotational mechanical system. Okay, so on the linear part, on the linear mechanical system, we have three passive components. That is spring, damper, and mesh. Okay, and then we want to what we want the meanings the linear mechanical system is based on the translational motion. Okay, they're based on the translational motion, meanings the movement is based on linear. Okay, but meanings the movement is about the movement is based on left to right or something like that. Okay, the movement of the linear mechanical system. But when we compare with the rotational mechanical system, they also have a three passive components: spring, damper, and inertia. Instead of linear, they have a mesh as a passive component. But for rotational, we have inertia. Okay, and then from here, the movement is based on the rotation motion. Okay, instead of the translational. Okay. So you can see from the table 2.4, if from our textbook is a page 69. Okay. So from here, we have three components: spring, damper, and mesh. And then also you can see the relationship. Okay. You can see the relationship between force velocity, force displacement, and impedance. Okay, but from here we always use relationship between force displacement and the impedance. Okay, same with the electrical circuit just now. We analyze the circuit based off the impedance. Okay, now also same with the mechanical system. We want to define the transfer function. We dealing with the relationship between force displacement and the impedance for the passive components: spring, viscous damper, and the mesh. Okay, for the spring, the impedance is a K. Okay, viscous damper FVS. This one FVS. And mesh is a ms square. Okay, so relationship between force and displacement, you can see for spring is a F is a total of force. Okay, F total of force, K is a spring, and X is a displacement. Okay, and same goes to the viscous damper. Force equal to FV dx over dt. Okay, and then for mesh, force equal to m d square x over dt square. Okay, that's show the relationship between force and displacement. And then the last column is for impedance. Impedance for spring, impedance for damper, and impedance for mesh. Okay, so how we want to simplify the equation? Okay, meaning single equation. Okay, meaning single equation. How to define, how to derive the equation is a sum of impedance you multiply with the x. X is a displacement. Okay, x is a displacement. X a displacement or translational. Okay, displacement meaning x. Hold on, force velocity. Displacement. Sorry, displacement of relationship between force and displacement. Okay, now single loop equation. Sum of impedance you multiply with the x. Okay, the displacement equal to sum of applied force. Okay, if a double loop meaning we simplify based on the mesh analysis. Okay, But very simple for the single loop. But for the second loop equation, we do as a mesh analysis. Okay, sum of impedance connected to the motion at x. This one, okay, minus sum of impedance, meaning between x1 and x2. Okay, this is number two, and then the last one is a sum of applied force at x1. Okay, so let we see the example. Okay, this is a one loop example for one single loop. Just now I mentioned to you we have a single equation, double loop, or multiple loop equation. Okay, and then we let we show the single loop. Okay, from here I show free body diagram. What's the meaning free body diagram? Okay, this is a free body diagram for the single loop. Okay, this is your system. Okay, this is I give you single loop linear motion system. Okay, this is a free body diagram for that system. Okay, so how we want to label the free body diagram? Okay, so meaning from here, you can see from the linear motion system, you can see we have a spring, we have a damper, and we have a mesh. And this is a total, let's apply force to this way. And then this is the displacement. Okay, X is the displacement. Okay, now we apply the force meanings to the right. Okay, of course, the movement or the displacement also to the right. Follow the position of the where we apply force. Okay, we apply force to the right. Okay, so how to draw the free body diagram is spring, viscous damper, and the mesh will be the arrow will be opposite. Okay, the arrow will be opposite compare to force the force position, and the displacement arrow. Okay, so you can see from here, this is the movement of the spring, and then the movement of the viscous damper, and this is the movement of the mesh. Okay, there will be opposite direction. Okay, this is the direction we apply the force. We give force to the right, arrow to the right, and of course this is the movement also to the right. And then the rest, spring, viscous damper, and the mesh will be the movement is the opposite. Okay, so how to find the transfer function from this free body diagram? Okay, from the free body diagram. Okay, from the free body diagram, we define the transfer function. Okay, here, to find the transfer function, find the differential equation of motion. Assume the positive direction of motion is to the right. Okay, meaning positive direction meaning is the force. Okay, so how to define the equation for this single loop? Okay, this is all the x. X is the motion, meaning a translational motion for this linear motion. Okay, you remember just now I give you the single loop equation. How to define the single loop equation? Okay, sum of impedance multiply with the translational motion. Okay, equal to sum of applied force, meaning our force is a F. Okay, from this circuit. Okay, this is our sum of total of force. Okay, so meaning what's our passive component? Meaning K for spring. This is the impedance. Okay, the impedance of this is the relationship between where is the between this one the this one, right? With the relationship between force and displacement. Okay, so X is our displacement. So what's the total of force? Force for spring, total of force for viscous damper, and total force for mesh. Okay, so from this table, you derive this equation. Okay, for the spring, so for the spring, we get this one. Okay, that's the relationship between force and displacement. Okay, this is for damper, and this is for mesh, and then equal to what? Equal to total of total of or equal to sum of apply force. So we can get this equation. Okay, so let me see. So from here, how to define the transfer function? How to define the transfer function from this one? How to define the transfer function? Hmm? How to define the transfer function from this linear motion system from single loop equation? How to define the transfer function?
Use Laplace.
Okay. Sorry? We
Use
taking,
Laplace. No.
yeah, yes, use Laplace transform. Okay. From this one, we taking Laplace transform. So we can get this one. Okay. So we taking Laplace transform, we can get mesh is a ms square x. Okay, and the damper and plus the k and equal to applied force. Okay, from this equation, we derive the transfer function. Okay, x meanings is our, what is x? X is our displacement. Okay, displacement out is our output over force is our input equal to 1 over ms squared plus mvs plus k. Okay, from transfer function, we draw into the block diagram. How to draw into the block diagram? Because this is our input and this is our output. Okay, this is a transfer function for that system from single loop system. Okay. Okay. So how about this one? Siapa boleh buat equation ni? Oops. Sekejap, sekejap, sekejap. Okay. Who want to try to solve this example. You use the sorry. Okay. Okay, how to solve two degree of freedom, or how to solve the double loop equation. So the easy way, you have to use mesh analysis. Similar, you do the analysis on the electrical circuit. Okay, we use the mesh analysis. Okay, how to solve for this one, double loop equation? So meaning we have x1 and x2. Okay, we have two displacement. Okay, we have two displacement, and then we have two mesh, m1, m2. Okay, and then we have three spring, and we have three also damper, viscous damper. How to define the transfer function? The transfer function is x2, meaning displacement number two over force, over apply force. Okay, how the first step, how to derive this equation? How to derive the equation? So we have to derive based on mesh. Okay, how mesh we have for M1? How to derive for M1? How to derive M1? Who can give me how to derive the M1? Okay. So we have to derive the equation on each what, on each mesh. Okay, due to, meaning for M1, that's due to displacement x1. Okay, for M2, due to displacement x2. Okay, so now number one, for mesh, we try to derive mesh number one. Okay. What equation you can do derive from here? You use the previous, okay. You use this simplified equation, double loop equation. Okay, sum of impedance connected to the motion at x1. Okay, the impedance you multiply with x1 minus sum of impedance between x1 and x2. Okay, multiply with x2 and equal to sum of applied force at x1. Okay, let's say you see from here, where is our one from this loop? Okay, how to derive mesh 1? How to derive mesh 1? How about what's the impedance related to x1? What's the impedance related to x1? We solve, how to solve? What is the, what's the impedance related to x1? What impedance? What the impedance connected to the motion at x1? Siapa boleh bagi? So meaning m s squared m1. Okay. Hold on. Okay. M1 S, kita buat dalam S domain we write in term of a domain. We list down here all the impedance relate to X1. Which one? Mesh K1,
F F1.
okay,
FV1, FV1.
FV1, FV3,
F2.
and K2. Okay, this is all related to X1. Okay, so now how to derive? How to derive? So ms squared plus we have 2 damper plus FV 3. Okay, this is all S multiply dengan S, meaning both ada S lah. Okay, plus dengan we have 2 spring, right? Betul tak? Kita ada 2 spring, and then multiply dengan we multiply with X1. Betul tak? Okay, dia akan jadi macam ni. Okay, is it correct? Like this? And this is in term of X. Okay, and minus, we minus with the we minus with the impedance related to what? Related to X1
Mm,
and X2. Okay, meaning we minus with the impedance between X1 and X2. Okay, so jadi apa? Which one is related to motion X1 and X2? FV3
two.
and K2, right? Okay, good. So equal to FV3S plus K2 and darab apa ni? X2. Okay, and equal to what? Equal to equal to equal to sum of applied force
Oh,
at X1, kan? So apa yang dekat for X1 kita? So total of force tu lah equal to Fs. Okay, this is equation for M1. Okay, so how about equation for M2? Macam mana nak buat equation for M2? Okay, number 2, mesh number 2. How to derive mesh number 2? So meaning, what's equation related to M2? Related to M2,
E-
FB3,
FV3, K2,
M2, FB2,
FV2, V.
K and M2. Okay, so you list all the impedance. Okay, you list all the impedance, meaning this is your M2S squared
Okay.
plus we have FV2
FV2.
plus FV3 S, is it? Plus, and how many K? We have 2K, K2,
K2, K3.
yeah, K3. This one is we multiply with the X2S kan?
S.
Okay, right. And minus with apa?
FV.
Minus with apa? Two impedance between X1 and X2. So now is we minus with K2, K2 plus FB what? FBV3, S, ada S the impedance, okay? And multiply dengan apa ni? Betul tak?
X1.
Kan? X1 kan?
Uh-uh.
Equal to? Equal to
Force.
apa? Ada tak force dekat X2?
Tak.
Tak ada,
Ada.
because our force, okay, you can see from here, our force is here. Okay, our force is at x1. So meaning dekat x2 tak ada force. So kita samakan dengan
kosong.
kosong. Okay, so samakan dengan 0. Equal to 0 from mesh number 2. Okay, because our force is at x1. Okay, here. This is our force here. Right? Okay, from this equation, we have two equations. And then what's the transfer function we have to define? We have to define this transfer function. X2, meaning motion number 2 over applied force. Okay, so we have two equations. How to solve these two equations? Do you heard before Cramer's rule?
Yes.
Okay, so to solve this equation, we have to apply Cramer's rule. Okay, you have to apply Cramer's rule. Okay, this is the solution, or this is the two equation belong to M1 and belong to mesh number 2. Okay, so you have to use the Cramer's rule. So this is, Madam need everybody go through this slide after this, okay? How to use the Cramer's rule, okay? Jangan tak tengok So ni Madam tak cover. Maksudnya Madam nak you all belajar sendiri. I need everybody go through how to use the Cramer's rule for this example, okay? So I want to share you for another slide, okay? The Cramer's rule, I need everybody do as your homework, okay? How to solve the transfer function using Cramer's rule, okay? Okay, this is 3 degree of freedom. How to use 3 degree of freedom? Okay, that's similar also, but so we have 3, meaning we have 3 mesh just now. Okay, kita ada 3 mesh. We have 3 mesh. We have a mesh number 3, mesh number 1, number 2, number 3, meaning we have 3 mesh. So they call 3 degree of freedom. Okay, so from here you have to derive the equation 3 times, meaning we have a 3 equation related to 3 mesh. Okay, so this is also do as your homework. Boleh tak? But tak perlu solve lah. You just this one. See? Right. Do not solve the equation of motion. Ya, Cha.
Kalau kan ni kan exercise kan. Kalau macam just keluarkan yang Madam kata impedance dia apa semua-semua tu. Boleh kan?
Impedance saja. Maksudnya in term of apa? Macam tadi lah yang macam kita buat tadi ni. Kita buat equation di dalam bentuk ni lah. Dalam S domain.
Okay.
Betul ke? Syah tanya yang tu ke? Kita terus derive dia punya impedance saja. Maksudnya refer balik dekat table yang Madam share tadi. Mana table? This one. Okay, refer dekat impedance terus. Straightforward refer kat sini. Okay, the impedance, right? Okay, meaning spring, meaning you tak, biasanya saya buat dalam S domain lah. Kalau S domain, kita analyze based on impedance lah kan? Okay, except if the question ask you to analyze the circuit or the system using relationship force and displacement. So kena gunalah for displacement. Okay. So kalau based on question, okay, let's say based on question, see, in term of S domain. So terus cari dia punya impedance. Okay, terus define what's the impedance. Boleh? Okay, find the impedance terus. Sama juga macam yang tadi. Okay, let's say from the 3 degree of freedom. Okay, you just derive the equation, no need to solve. Okay, you jangan solvekan dia, derive the equation. M1, what's the equation for M1, what equation for M2, and what equation for M3. Okay, and then from here we have three motion. Okay, another one, where's another one, where's another one? Okay, this one. And your force is at X2. Okay, so cuba ya untuk yang ni. Sekarang dah pukul 1. Free ke tak free sekarang? Everybody free or not? Or you have class at 1?
Ada kelas at 2.
Ada kelas at 2. Oh, okay, okay, okay. So, Madam ambil sikit masa lagi ya. Give me about 10 minutes boleh tak? Can you give me 10 minutes?
Boleh. Boleh, madam.
Slow je jawab.
Boleh,
Boleh. Okay.
Boleh.
Okay, okay. Okay, thank you. Okay, just 10 minutes. And after this, we have another complex system, meaning combination of electrical and mechanical. Okay, that's call it electromechanical system. So that will be covered another day. Okay, let me finish for this rotational mechanical system. Okay, so this rotational also, instead of mesh, they have a inertia. Okay, kalau yang tadi tu is a linear mechanical system, we have a mesh, but for rotational, we have a inertia. Okay, but they also similar how to solve the transfer function. Okay, we also use the impedance also. Okay, this is the impedance. Spring also same with the linear. K, damper also same, but they have a different level. Okay, for linear we use FV, right? For the damper. Okay, damper. Where is the damper for the linear? Viscous damper. I label with the FV. Is it the impedance is Vs? But for the rotational mechanical system, the viscous damper we label with the D. Okay, the impedance for viscous damper is the ds, and initial is a Js squared, meaning kita Laplace transformkan dia daripada sini. Okay, Laplace transformkan. So, you akan dapatlah impedance dia. Right. So, macam mana kita nak solvekan dia? Yang ni tak ada free body diagram. Okay. That sama juga macam tadi tu. Single loop equation. So, maksudnya dia based on rotational is a angle lah kan, theta. So, you tengok dekat sini is a angle. This is based on rotate. Okay, dia rotate, right? So single equation, sum of impedance multiply with the angle equal to sum of applied force. Similar with the linear. Okay, instead of this one is a angular theta, but the linear we label with the x. Okay, the displacement. Again, also same with the double loop equation. Okay, you see here for double loop equation, this one, sum of impedance at motion theta 1 multiply with the theta 1 minus sum of impedance between x1 and x2 and equal to apply force. Apply force tu depend lah dekat mana. Dekat mana dia applykan force. Whether, ni bukan x tau. Sebenarnya apa ni? Ni bukan x, ni adalah angular. Okay, this is the angular, not x. Okay, this is not x. Ini dia dah salah kat empis kan ni. This is not theta 1. Okay, this is also theta 2. Okay, based on angular. Okay. So for multiple loop, meaning we have a 3 loop or a centra. Okay, that sama saja macam mana you nak define or macam mana you nak simplify the equation adalah based on mesh analysis tu lah. Based on sum of impedance multiply with the apa dia punya angle dekat situ. Apa dia punya angular displacement dia. Okay, contoh dia. Contoh dekat sini. One equation of motion. Okay. So, let's say lah the medium need the because the time function adalah is a angular displacement, meaning this one. I want you to define this transfer function. Theta over T. T is your, what is a T? T is a total of top. Okay, T is top. Okay, T is a total of top and theta is an angular displacement. Okay, now we have to define the transfer function of the system is an angular displacement as the output. Okay, angular is your output and over T. T is your input. T is your top. Okay, from this single loop. Okay, so how you want to derive the single loop? Okay, how to derive the single loop? So meaning they have a damper, inertia, and K. So we list, okay, we write the impedance for the three passive component. So meaning Js squared for inertia multiplied with the angular displacement, okay, and then ds is the impedance for the damper and K impedance for the spring, and all this one is we multiply with the angular displacement equal to what? Equal to apply meaning equal to sum of applied force at angular displacement. Okay, so equal to T. Okay, equal to total torque. So you simplify the equation so you can get the transfer function. Okay, so that's for single loop. Okay, how to solve this two equation of motion? Macam mana nak define this one? Is it they also similar with the previous one, linear? We have J1, we have J2, so we have to derive one by one. First, you have to derive your J1, and after that, you have to derive your J2. So, J1, how to derive the J1, initial one? What's related to angular displacement number 1? Apa component what's the impedance connected to angular 1 or
Okay.
angular displacement 1? Okay, sorry. Okay, so meaning first is sekejap ya. Oops, sorry. So meaning we have K lagi, we have
D1.
D1 and we have initial kan. So apa dia punya equation dia? J S square kan? Betul tak? J S square ya? Kejap kita tengok table. Ya, J S square plus D1S, kita ambil evidence dia, and plus with the spring. Multiply with the theta 1 kan? Okay. And minus apa? Minus with what? What's the impedance between X1 and X2?
K.
Okay, good. Minus with K multiply with the K is related to theta number 2. Is it? And equal
to 0.
Where is the top?
TS.
Our top. Okay,
Yes.
top kita adalah our T is a sum of top apply at angular number 1. So ni sama dengan TS lah kat sini. Okay, this is equal to, sekejap ya, Medan gerak sikit ni. Okay, this is equal to CS. Okay. So how about equation number 2 for J2?
Okay.
For J2, what's impedance connected to angular 2?
JS square plus K.
J number 2. Okay, just now J number 1. Okay, JS squared plus D2. Okay,
D2S
D2S. Betul. Plus
K.
K. And this is multiplied with the angular number 2, right?
Ah,
Okay, minus.
K.
K.
Okay, minus K multiplied with angular
Ah,
number 1
1.
kan? Okay. And this equation equal to?
0.
Yes, very
0.
good. Equal to 0. Okay. So this is also same. You have to use the Cramer's rule to solve the transfer function
Answer.
because we have two equation. Okay. So we have to apply Cramer's rule how to define this transfer function. Okay. Angular 2 over D. Okay, this is the equation we derived just now. Okay. So label also wrong. Is it? Madam ni main salin je. Betul tak label salah? Ni sebenarnya apa? This is J1 kan?
Ah,
Sorry ya. This is J2. Tengok dalam puasa ni buat nota. Okay. All top on J1. All top on J2. Okay, right. Okay, this is using Cramer. So, dapatkan the transfer function. Okay. So, let's try exercise 2.21, 3 degree of freedom. Okay, similar also, don't solve. Okay, just write the equation. See, this one. Okay, just write the equation for what's the J1, what's the equation for J2, what's the equation at initial number 3. Then, okay, you only just list down. Okay. And this exercise, let's try how to, from page 44, okay, this is also try, okay, this exercise and then this page 43 and 44. Okay, boleh tak as your homework? Okay,
boleh.
now we, okay, just try, okay. So now we finish, okay, we finish our rotation, sorry, mechanical, our mechanical system. Okay, we finish our mechanical system. Hold on, this one. Okay, we finish model of mechanical system. How we want to define the transfer function for mechanical system based on linear mechanical system and rotational mechanical system. Okay, so for the next meeting, we will cover on electromechanical system, meaning the combination of electrical and mechanical system. Okay, mechanical, yeah, electromechanical system. Okay, so how everybody? Is it okay?
Okay. Okay.
Okay.
Okay, hopefully okay. So after this, saya akan apa ni? Will be shared like I give you a few of example